All right, this is sections 1.3 and 1.4. They were supposed to be part of the first video, and for some reason the audio cut out, so I'm redoing them here. So we're looking at graphing linear equations. Specifically, we're going to only be talking about lines in this section, and we'll be looking at also how to use some formulas to write some equations. So that is the focus of this section. So let's start off with talking about the formula y equals mx plus b. This is for a line whose slope is m and y-intercept is 0b. This is the format we use when we're trying to graph lines quickly. And to get in this format, you have to have y by itself and then everything else on the other side. So when you're in that format, then m is the rise over run, and that's next to the x, and b is where you cross the y-axis. So your steps for plotting this are going to break down into 3 steps. You're going to have plot the b on the y-axis since it's a y-intercept. 2, you're going to use the m to rise, run, and we'll talk about what that means, to find a second point. And 3, you're going to draw the line. So draw your line. Okay, so let's look at this first one here, y equals 4x minus 2. That is definitely in slope-intercept form. And this is -2 for the y-axis. So we'll go down to the y-axis at -2, put a point. So my y-axis point is 0, -2. My slope is 4 over 1. Now when I'm graphing, I do write that as 4 over 1. If I'm writing the equation, I just say it's 4. But this is to help me see rise and run. So the number on top tells you if you go up or down, if it's positive or negative. And the number on bottom, if it's positive or negative, tells you if you go right or left. So since both of these are positive, this is up and right. Now there is an alternative here. The slope could also be positive 4 if both top and bottom were negative. In other words, they were their opposites. If that happens, you would go down and left. And what you'll notice, I'm going to do both of these, is that they're on the same line. So up 1 from the point, 1, 2, 3, 4 over 1. So that's my first point. Or I could have gone down left, or excuse me, down and then left. So 1, 2, 3, 4, and then left 1. So notice these are both on that same linear equation. And we put arrows on the end to let everyone know that this graph goes on forever. Okay, for this next one, we're not quite in the right format yet. We need to be in slope-intercept here. So if we want to solve that, we'd have to subtract over the 2x. So then my y-intercept is 0, 6, and my slope is -2 over 1. So this would be down and right. Another way to write -2 is to write it as 2 over -1, which would be up and then left. So you could do either or. So +6, so 1, 2, 3, 4, 5, 6. And then I'm going to go down 2, right 1. That's one of my points. Or I could go up to left 1. And notice they're in the same line together. Now the next 2 are special lines. This is a vertical line because notice the x is the only variable there. If you don't have both x and y, you have a special line. And what this means is that we're stuck at x equals 1 forever. So in other words, we can go up and down because that's still x equals 1, but we can't go left or right because that would change our x value. So you just get this vertical line at the value x equals 1. And then this one is y equals -4. So we go down to -4 on the y-axis. And again, I cannot change my y value ever. It is fixed. There's no x to change it in the equation. So x's can be anything we want, but the y's are fixed. Now, in terms of these 2 last graphs that we did, they do have special slopes. This first one, the vertical line, when you do a vertical line, you have a rise, but you have no run. So that's like a 0 on the bottom. Anytime you have a 0 on the bottom, that is undefined. Okay, and on this one, we have the run. Definitely, we have lots of run, but we have no rise. So that's like having a 0 on top. And I have no idea why that guy jumped up there. But that means that it's m equals 0. So we'll just go ahead and use that. So those two are special slopes. Horizontal lines have 0 slope. Let's write that this is horizontal. And vertical lines have undefined slope. Okay, the next piece of this is point slope equation of a line. So the slope m, if you don't have a picture where you can count the slope, then you would want to find it by using a formula. So you'd need two ordered pairs, and we call them x1, y1, x2, y2, just to name which one's which. And then the slope is found by change in y over change in x. That's what those little triangles right there mean. So y2 minus y1 over x2 minus x1. You could easily do y1 minus y2, but you have to be consistent and do x1 minus x2 in the bottom. So you have to start with the same ordered pair on top and bottom for the where you pulled out the x and y from. And it is important. If you put x's on top in this formula, you do not get the slope. You get the reciprocal. So it has to be y's on top. So y's rise. That's always how I remembered it. And then we said the slope is not defined for vertical lines. This formula right here is called point slope. It is a format that sometimes we leave our equations in, and sometimes we use it to solve to the other two formats. It uses an ordered pair and a slope, so that's why it's called point slope. Slope-intercept form is y equals mx plus b. We've already seen that one. And general form is everything's on one side, and there are some specific things you need to do in this one. In this one, a, b, and c are not fractions. That's one rule. And usually they want a to be greater than 0. It's not always required in every single textbook, but that's a standard condition. Now, you can have fractions in slope-intercept and in point slope, but they do not allow them in general form. And notice it's the constant in front of x plus the constant in y plus the constant that has no variable. So that's the order that it needs to be written in. Okay, so for these two right here, we'll save the rest for in class. We're going to do all three formats. So let's start off with this first one. And we're looking at, it's a point and a slope. So let's start with point slope. So y minus y1, so that's this y value, equals m, which is -4, x minus x1. Now notice these are minus and negative, so I'm going to fix that. That's going to change to plus. Now, once I fix that, I would say that if someone said write your answer in point slope, this would be appropriate. So this is point slope. Now to get it in slope-intercept, I'm going to distribute the -4 and then subtract over the 2. So this would be -4x minus 4. Subtract over the 2, that'd be -4x minus 6. So now if someone wanted my final answer in slope-intercept, I could say, now here it is. And then to get it in general form, we move everything over to the left. So we'll add both the -4x and the -6 over, and they become positive. You do want to make sure you put things in the right order. The y was already over here, but it needs to be in the middle. So this would be what we call general. And it has no fractions, and the a is positive. Okay, so let's look at this other one. This one has a fraction and a fraction, so just a little bit harder. So this would be y minus 0 equals, m, which is 1/4, parentheses, x minus 8/3. And since there was no minus and negative here, this is already in point slope. So that's good to go there. Now it's a 0 on this side, so that means that's already just y. So I just need to distribute my 1/4. So this would be 1/4 x. Now when you distribute fractions, make sure you multiply top times top, bottom times bottom. So that's -8 over 12. So that would be dividing by 4, that'd be -2/3. You could also reduce the 4 and the 8 when you do that. But sometimes students mess up when they try to reduce all at one step. And then, so this would be slope-intercept. So there we go on that. And then the only other form I need is general form, and unfortunately this has fractions. So what I do to fix this is I multiply everything in the equation by the LCD of 4 and 3, which would be 12. They both go into 12 evenly. So we multiply everything, and this is just an algebra trick, in the equation by 12. Okay, so that's going to be 12y, that's going to be 3x, and minus 8. Now this is not in general form yet because we need it all on the left. So subtract the 3x over, we have the 12y already over there, add the 8 over. But unfortunately, even though the fractions are gone, this sometimes would cause issues depending on what book you're using or what your teacher's rules are, and they may say you have to have a positive in front. So all you have to do to fix that is multiply everything by -1 or change all your signs. 0 doesn't change because it doesn't have a sign. So there are the versions of each of those. Okay, the only other thing we need to do in this video is we need to do a little bit of groundwork in section 1.4, which is over functions. So a function is a relationship between two variables such that to each value of the independent variable there corresponds exactly one value of the dependent variable. Now that's fancy book talk. This means input variable. This means output variable. So for us, that usually means x and y. So it means that in an ordered pair, if you have 1, 3 as an ordered pair in your function, you can't have 1, 4, because that means that the 1 was not unique. That's the main thing for being a function. You have to have the x value can't be used with different y values, because that will, if you see on the next part, that's going to fail the vertical line test. The vertical line test is used if you're given graphs and they ask you specifically what is the possibility of this thing being a function. So if you draw vertical lines all the way across the graph, if it's a function, each vertical line will only touch your curve or graph once per line. If that happens, then it is a function. If it doesn't happen, it is not a function. It's just an equation that was graphed. A function can also be one-to-one if the y values also are unique. So to test that, you have to first of all pass the vertical line test, because you can't be a one-to-one function if you're not a function. And then to test if you're one-to-one, you do the same idea, but you do it using a horizontal line test. So I'm going to show you both on these graphs right here. So determine whether each graph represents a function. If it is a function, decide whether it is one-to-one. So we're just going to do some vertical lines across this guy. Notice each of those only crosses my x plus y equals 1 once per red line. So yes, this is a function. Now, the question is it a one-to-one function? So then I do blue, and I come across horizontally. Now again, these are crossing my red lines, but we're only looking at, does the blue line cross the black line once per blue line? And it does. And it's 1-to-1. Okay, so this one is 1-to-1. The circle will immediately fail the vertical line test. It crosses it twice. So this one's not a function, which means we don't continue with the horizontal line test because it has to be a function first. So this one's passing the vertical line test as we go from left to right. I know those don't look vertical, but imagine vertical lines. They don't cross anywhere more than once. So yes, function. But when you go to do the blue lines for the horizontal line test, again, we're failing now because we're crossing that black line twice. So not 1-to-1. And then the last one fails the vertical line test, so not a function. Now this is useful for us because if something is 1-to-1, it will have an inverse. And if something is not 1-to-1, we can ask, can we force it to have an inverse using maybe part of the graph and not all of the graph? And that's going to also rely on another topic we're going to review, and this is the last one for the video. What is domain and range, and how do you tell it from a picture? Now, the big part will be telling it from an equation. That's going to be covered in class, but a picture kind of helps set the tone for that. So domain and range of a function is a set of all values of the independent variable for which the function is defined. In other words, it's the input values. So what's the x's for us? The range is the set of all values taken on by the dependent variable, the output variable, which is a y. So we're going to find the domain and range of each of these. And the easiest way I've found to do it is just to kind of, I'm going to use a highlighter here. If you talk about the domain, you're talking about the x-axis. So imagine this yellow highlighted line. Anywhere, if I grab a point and I look up or down, if I can find part of my function there, then I know that this graph uses that as part of its domain. Now, unfortunately, the graphs aren't perfect, and these are going down forever past the graph. So you have to imagine this keeps going wider and farther out. So any point we pick, we can find a point on this graph. So that means the domain is all real numbers. And the way we write that in math class is we write negative infinity to infinity in interval notation. This means every value between negative infinity to positive infinity. Now, we don't use brackets on these guys because infinity is a concept, not an actual number. It's an idea. If you include a number, you usually use a bracket, and we'll talk about that with the range. So let's look at our y-axis. So if you're going up the y-axis, just bebopping along. up through here. Notice that if I'm down here, yes, I can find plenty of points on my graph. In fact, I have some on left or right. But the problem is once we get to 1, after that point, there's no more graph above here for y. There's never going to be a point on this curve that has 2 for its y value. So this means that this is a range that is restricted, and you go from least to greatest. So this goes from negative infinity up to 1, and the point is actually there. So if it was an open circle here, we would say parentheses, but because the point exists, we say it stops at 1. Okay, so let's finish this out with this last one. Oh, that's way too big. So looking at this right here, the x-axis for our domain, notice that there's no graph for, up or down above any of these until we get to about right here. This is 3/2. It's halfway between, so 1.5, halfway between 1 and 2. So my domain starts at 3/2 from left to right, because remember you go from least to greatest, and then we use every x value after that because there's graph above it. Now my range, we need to use the blue. Notice I'm going from down here up above. Now, there is no graph down here left or right. That's just my number I wrote in. So the graph doesn't actually start till at 0, right here. This is where it starts. That's the first time we see a point. So this would be from 0, and then even though you don't know it, this graph is continually, since it's at the edge, going up and out. So it's going to keep going up with the graph. So that would be all the way to infinity. All right, hope you guys enjoyed this video, and that reviews a lot of the stuff from algebra class.